Hello, my name is Richard Oler, and this is my final project for Statistics 2023-26926. Why I chose this project: I have green eyes, and I have heard that they are rare. I wanted to know just how rare they are. My research question is, do you have green eyes? What does the data represent? The data represents the percent of people who have green eyes. What is your alpha and why? The alpha is 0.05 because it is standard. My sampling procedure. Describe my sampling method. I created a survey using Google Forms and posted a request on several Facebook groups to have people take the survey. I received 116 responses. Who is the population? The population is all Americans. Who is the sample? The sample is 116 people that responded to the survey request. What did you do to avoid bias? I posted publicly in groups on Facebook and let random people respond. I chose the groups to represent localities such as Lakeland, Kissimmee, Osceola, and Orlando. By using geographical areas, I hoped to avoid any ethnic bias that could affect eye color. The question was, do you have green eyes? My data included 116 total responses, 5 yes and 111 no. This is my graph. Do you have green eyes? The majority of those samples said no, which represented 95.7% or 111 out of 116. The percent of those that said yes is 4.3%, which is 5 out of 116. My hypothesis test. My HO was P equals 0.09. The proportion of people who have green eyes in the United States is 9%. My HA was P is less than 0.09, which I'm proposing that the proportion of people who have green eyes in the United States is less than 9%. My citation comes from Warby Parker. Green eyes, how rare are they? Which was an article they produced on October 16th, 2024. Check the condition. Condition 1, it was random and independent. The data was collected randomly. Condition 2, large sample. The population of all Americans is greater than 10 to 116, which is all Americans are greater than 1,160. Condition 3, big population. N times P is greater than or equal to 10, which ends up being 10.44 is greater than or equal to 10, and 105.56 is greater than or equal to 10. So all conditions are met. My hypothesis test continued. This is my work. P equals 0.09 for 9%. P hat is 5 over 116, or 0.043%. N equals 116, which is my sample size. My standard error is 0.027. My Z is negative 1.74, which ends up being slightly different than what I have on the calculator, but very close. On the calculator, I came up with Z equals negative 1.76. And then my P equals 0.0388, which is the rounded of P. Conduct the test and label your test statistic and provide your p-value. My test statistic is Z equals negative 1.76. My p-value is 0.038. And this is my graph for my hypothesis testing for P. Since the p-value is 0.0388, and that is less than the alpha of 0.05, the conclusion is to reject HO. I reject HO. There is statistically significant evidence to reject HO, but my p-value is 0.038, which is less than my 0.05. I conclude the proportion of Americans who have green eyes is less than 9%. My confidence interval ends up being 0.096 and negative 0.001, which is close to 0. So I went ahead and rounded over to 0 and wrote, I am 95% confident. The proportion of Americans with green eyes is between 0% and 9.6%. And again, that's because there can't be a negative percentage in this. I'm glad I picked this topic. I knew green eyes were rare, but I didn't realize how rare. In gathering data for this project, I learned that worldwide 2% of people have green eyes, which I think reflected in my result. That is, that my result showed that it was less than 9%. Although my data set was small, so was the original statistic. They had only surveyed 2,000 people. I would like to see a larger scale study done. This concludes my project.